Here we're going to add on a couple more formulas now that we know the formula for average cost and actual cost. We're going to add in the formula for revenue and profit. These two are very intuitive. The first one, revenue. Revenue is your daily income. So you would find that by doing X times P, which makes sense. It's X, the number of things you sell, times P, the price you sell them for. So if you sell 10 $5 items, your profit is going to be 10 items sold times $5 each, $50. Our other formula is for profit. Profit is your revenue, how much money you got from your customers, minus the cost it took to create something. So we just said we sold 10 $5 items, our revenue was $50, but maybe it cost us $20 to make those items. So our profit would be our revenue, $50 from selling things, minus our $20 it takes to make them. Our profit would be $30. Keep in mind that profit can be negative. That's when your cost outweighs your revenue. It costs too much money compared to what you're selling it for. So we have a marketing company has determined the following function for the demand for 40-inch smart TVs is given by this demand function, P. And here we have this interval. We're not going to do too much with this now, but we're going to keep in mind they can only make between 0 and 15,000 TVs. So we're not going to say, hey, to maximize your revenue, you should make 45 million TVs every day. That wouldn't be something that they're capable of doing. So with their demand, they're stuck between making 0 and 15,000. So we'll only keep that in mind when we're giving suggestions in our answers. We want to stay within that domain. So P is going to denote the unit's price in dollars, and X denotes the quantity demanded. So first thing we can find is the revenue function. I'm going to write out the formula again. The more we write it, the easier it's going to be to remember. So revenue is X times P, number of things you sell times the price you sell them for. So for this one, it's going to be X times our P above there is minus 0.08 X plus 600. And then we need to distribute here. So our overall revenue function, we're going to multiply the X through. So we're going to get negative 0.08 X times X will give us X squared. And then X times 600 is going to give us 600X. There's our revenue formula. So when I write this, I usually put some arrows when I'm memorizing this formula. It's going to be X times P, and I put arrows on top because you're always going to have something to distribute when you have more than one term in your demand function. Next piece it asks for is marginal revenue. This isn't a formula that we've gone explicitly over yet, but we know marginal means take the derivative. So all I'm going to do is take the derivative of my revenue function, and that will tell me marginal revenue. So we want to remember that first we would bring down our power. So we're going to multiply here. Be careful, don't square that. It's negative 0.08 times 2, which is going to be negative 0.16x to the first. And then the derivative of 600x is 600. So we took the derivative of revenue to find marginal revenue. And now the next thing says, determine the number of 40-inch smart TVs demanded to produce the maximum revenue. So this is super important. They want to figure out what's going to maximize their daily income. So we want to tell them what's going to make them the most money. We want to remember that to find the maximum of anything, if you wanted to find max revenue or min cost, max and min are found by taking the derivative and setting it equal to what? Take that derivative and set it equal to 0. We're going to find our critical number here. This one's nice to solve. It doesn't have an x squared and an x, so we don't have to factor this, which is great. We just need to get x by itself. We can do that by first subtracting 600 from both sides. So we would get negative 0.16x equals negative 600. And then the next thing I can do to get x by itself would just be to divide by negative 0.16. And I could grab my calculator and plug in what is negative 600 divided by negative 0.16. A negative divided by a negative is going to make a positive, which is good because we're talking about the number of TVs. So our critical number is 3,750 smart TVs. But we're going to check. We remember critical numbers can be relative max, relative min, and they could be neither. So we're not going to tell this company flat out, hey, go with 3,750, because we could accidentally be minimizing their revenue. Or it could be neither a max or a min. So we're doing 2 steps to find relative max and min always. The first step, find your critical number by taking the derivative, which we already did in part B, and we set it equal to 0. And then we also want to check that it's actually going to maximize their revenue by making a sign chart. The first thing to go on our sign chart is our critical number. This makes r prime 0, makes the derivative 0. So it's either a flat part of the graph, or it could be the top or bottom of a soft peak would have a derivative of 0. So we just want to make sure this one is a relative max. We don't want to minimize it or just have it be a random flat part of the graph. We want to see that it's a maximum. So we can test any numbers before and after our critical number. It might seem silly to plug in 0, but that's my favorite thing to plug in on this first interval to the left. We're always plugging into the derivative on a sign chart. So I'm going to do r prime of 0. So when we plug in 0 to the derivative, we get 0 plus 600. Negative 0.16 times 0 is just going to be 0 plus 600. This is definitely going to be a positive. So far the derivative says that the function must be increasing before our critical number. After the critical number, we can plug in anything we want to. And we want to probably keep in mind that we're on this interval from 0 to 15,000. So I'm going to plug in something bigger than 3,750, but still on that interval that we're interested in. So maybe 4,000, and I might need to grab my calculator and do negative 0.16, that first part of the derivative, times 4,000 plus 600. When I plug it in, I'm getting negative 40. So I plugged into this derivative here, it's written up here as well, and I'm getting negative 40. So we're getting a negative derivative, which means we went from increasing to a 0 derivative at our critical number back down to decreasing. So this is definitely going to be their relative max. So they should produce 3,750 TVs if they want to maximize their revenue. And then part D is really the next question they're going to ask you. So they would say, how much should we produce? We would suggest 3,750. And then of course the very next question would be, how much money are we going to make off of this? So we want to see what the Y value would be for that X value. So we don't want to plug this into the derivative. If you make that mistake and you plug in 3,750 to the derivative, you're going to get 0 out. Remember, it made the derivative 0. So we definitely don't want to plug in there. We want to figure out the Y value, which means we need to plug into the original. I'm going to plug into the regular R from part A. R of 3,750. Let's see how much revenue they're going to make off of these TVs. You have negative 0.08 times 3,750 squared plus 600 times 3,750. When you plug into negative 0.08x squared plus 600x, plugging into that original function, you would obviously probably need a calculator for this. And what I'm getting in my calculator is $1,125,000 as their maximum revenue. So you would say, hey, we suggest, based on our analysis, that you should try to produce and sell 3,750 TVs, and your maximum revenue off of that should be $1,125,000. But we want to remember that revenue isn't the end-all be-all. There's a couple formulas in that box up there for a reason. So revenue is their income. Yeah, they're going to make $1.125 million off of these sales, but we want to figure out what's their profit. That's going to take into consideration how much cost it makes to produce these smart TVs. So we want to see what's happening with profit, which will be on the next page. So we have that same television production company says that it estimates the total cost in producing X TVs is given by the C of X is 180X plus 200,000. So we have their total cost, and we're going to use that to find profit. So we want to remember profit is your revenue, how much money you make from sales, minus your cost, how much it costs for you to produce these items. So let's see what the profit function is. So profit, we'll write it here. Again, it'll help us memorize it. It's revenue minus cost. And I'm going to put the little arrows on it because we're going to have to distribute. So we want to find the revenue function, which we already have in part A. Revenue was negative 0.08x squared plus 600x. We're going to take that, negative 0.08x squared plus 600x, and we're going to subtract cost. The total cost function is given here, 180x plus 200,000. And if I write it like that, I will probably get the wrong answer. It's all of revenue minus all of costs. We have to distribute that subtraction. So our profit is going to be negative 0.08x squared. And then we have 600x minus 180x. So you could use your calculator if you need to. 600 minus 180 is everybody's favorite number. We get 420x. And then we have not plus 200,000, minus 200,000. Which makes sense. If we plug in P of 0, if we want to calculate our profit off of selling nothing, we should get a negative number. They've invested all of this money into having this big company in this big building with all of these employees, and they're paying taxes. And if they sell 0 things, if we plug in P of 0, they're going to have a profit of negative 200,000. If you had a plus 200,000 at the end, that would make absolutely no sense, because you shouldn't make $200,000 off of selling 0 TVs. So profit always has a big negative number at the end in general, because you've invested some cost and then you didn't make any money if you sell 0 things. So you might want to put a star on that. You want to remember to distribute, or else your answers won't make sense. So we found profit. The next part is to find marginal profit. Marginal means take the derivative. So we're going to take P prime of X. So we'll bring down that power. So negative 0.8 times 2 is going to be negative 0.16 x. Derivative of 420x is 420. And derivative of negative 200,000 is just going to be 0. It's a constant. So there's our derivative of profit. The next part says to compute P prime of 100 and interpret your results. So P prime of 100 is going to be negative 0.16 times 100 plus 420. You can grab your calculator if you need to. I'm getting 404, and this is dollars. And we want to interpret this. This is probably one of the hardest parts of this section. We've talked about interpreting marginal cost. We know marginal approximates the actual cost for the next unit. It's the same exact thing with profit. So we would say the approximate, because we know it might not be perfect, might not be the exact number, but the approximate actual, and be careful, this time we're plugging into P prime and not C prime. So the approximate actual profit instead of cost, the approximate actual profit, not from producing now, you have to sell in order to have profit. So the approximate actual profit from selling, and it's always the next unit. So we plugged in 100, so it's going to be from selling the 101st TV, or smart TV if you want to get super specific. The approximate actual profit from selling just that 101st TV is $404. Not a bad profit off of selling a single TV. But there's some practice using revenue and profit, and we're going to obviously do some more in the coming examples.